All right, so now instantaneous velocity. So the instantaneous velocity is the velocity at any given time, right? So again, if we were to graph this thing quickly, then when I'm talking instantaneous velocity, I'm talking, let's say right here, right? Maybe this was 3 seconds. So what would the speed be right at that point? And again, you can see, well, we'd like to bring those points, those of the secant line, closer and closer together so that we're just looking at the speed right there. And if you guys have taken physics, then you probably were able to figure out the instantaneous velocity by just kind of doing it on a chart and then figuring out the rise and the run, right? Now that we know calculus, we can use limits to do that. And in this case, it's going to be, well, derivatives again, right? But it really would be the limit in this case, right? So the velocity at any given point, so f prime of t, then we can use the limit as h approaches 0, right? So this is like the distance between those 2 points again, if you remember way back, right? So we're bringing that distance down, okay, down to 0. And then, well, this really is the derivative, right? Those are our first principles. So that would give us the slope at that point, the slope of the tangent line at that point right there, right? So that's the idea. And then you guys know we don't really need to use first principles every time we find derivatives anymore, right? Luckily, we know how to find derivatives. So let's kind of jump into it. We're just really going to be finding the derivatives of these things and then interpreting the meaning. So to determine the velocity of a function, we take the derivative of the position function, since velocity is the rate of change of position. Okay, so now this one says find the velocity of the function d of t is equal to 35t plus 8 at t is equal to 3. Okay, so a time of equal to 3. So let's find the derivative of that. So the derivative, so dt is equal to, and well, if I take the derivative of that, right, that's just equal to 35. So, okay, the derivative at 3 seconds would just be, well, it seems like it's always 35, doesn't it? And let's just check to make sure that makes sense. If we graph this linear relation, right, this would have a y-intercept at like 8, and then it, will go up as a slope of 35. Then if I'm saying at like 3 seconds, what's the slope? And we figured out it's 35. Well, yeah, that makes sense on a straight line, doesn't it? The slope is the same everywhere. It wouldn't matter what time we threw into that, right? Because we were dealing with a straight line.